Hello everyone. Today I want to explain to you the Sn1 mechanism. Effectively, Sn1 is different from Sn2 because Sn1 performs on bulky electrophiles such as this right here, where we have a carbon bound to 3 adjacent carbons, right? And then we have this X, which is a halogen or any form of good leaving group. And if we want to go ahead and look forward to see what is a good leaving group, some things such as halides like iodide or bromide. So when we look at our bulky electrophile in this situation and we see that there's a good leaving group, what happens is that this good leaving group can destabilize from the system here and effectively leave on its own as an ion pair, allowing this carbocation, that's the name of the carbon that has a positive charge, it is a carbocation, as whereas this is the anion. So the carbocation wants to be attacked by some form of nucleophile by the fact of electrons seeking center, or as it is called, nucleophile, so it is seeking the center, and the electrophile, which means that it requires electrons in order to be happy, is then sated by the nucleophile attacking it. So the most important part is that when we looked at Sn2 reactions, the fast step was just the displacement of the backside attack. However, the slow step here is the dissociation of the halogen or good leaving group, and that is the actual rate determining step. Since this is the slow step, that means that this is the rate determining step in this situation, because it takes a while for this to dissociate. When the nucleophile is in the solvent system and it is ready to attack, it will go so very fast because the carbocation is already prepared from the dissociation of the halogen or good leaving group. So finally, we are left with our happy little group here. One thing is that Sn2 does not like bulky electrophiles such as this here. An Sn2 reaction would not prefer that. Now, the classic Sn2 reaction would prefer something such as this. Is very easy for a backside attack to happen because it is clear. Right here, we can have a strong nucleophile. That's the point that was in the Sn2 that was important. However, here, any form of nucleophile that is pretty decent would be good. So if we were to actually take this forward over here and use water, what would we end up with? So this is something called solvolysis, and what that means is that the solvent itself acts as the nucleophile. So when we come to our final solution, the water molecule would actually turn into an alcohol. The reason is because at first when it would be bound as this, because with water has electrons that are free right there that can seek nucleus. The other situation that happens is then we have a positive charge here, which then can be dissociated into the system to go to our little friendly anion. So that is the main point to know, is that in a bulky system with Sn1 reactions, you will have a really good time going forward whenever it leaves because of the stability of the carbocation. And then we go forward with a fast reaction in a form of nucleophile attacking our electrophile. If you have any further questions on the Sn1 reaction, or you're curious at any more difference between Sn2 and Sn1, please leave a comment or send me a message, and I can even make you a personalized video explaining how reactions mechanism steps work. Thanks for watching. Have a nice day.